Today we're going to work on making some graphs. And we're going to calculate the data in SPSS, move it into Excel, and create our graphs in Excel. Excel makes much better publication quality graphs than SPSS. So the first thing we're going to do, we're going to use Eddie Chow's data. By the way, go to the bottom of your screen, pick options, and don't forget to press the one to speed me up. Then you can slow me down when you have a question about the exact buttons that need pushed. But in Eddie's data, we matched people on aspheric type lenses and spheric. After we ran the data, we saw that it was a bimodal distribution for the spheric. Some had poor control and others had good control. So we separated a little bit further. Now we're going to look at the baseline values for aspheric, spheric, good, and poor control. Now look at these values over here. We have a mean of 11, minus 4, 43, 49, 549. It's pretty hard to put on a single graph all of these baseline values with such disparate things. The scale is just too crazy. You'd see the central corneal thickness and miss everything else. So in order to do that, we're going to calculate standard scores. Now a z-score is calculated by an individual value x minus the mean of x divided by the standard deviation. SPSS is going to help us on this because it can do this for us, but we want to first calculate the z-scores for all the subjects. So we want to create an overall mean and standard deviation. So we go into our data split file. We had split this by lens type 2 to get these three things. We now want just a single file, and we combine them all. So let's go to Analyze, Descriptive, and then we have the variables that we're interested in. That's these right over here. And we want to save standardized variables or values as variables. So we check this box. Okay. And then we notice, well, first let's look and see what we got. So here there are 354 eyes. Here are their means and their standard deviations. And if we look in here, we can see it's added these z-scores. So now we have z-scores for every subject by and it's a z-score that is based on the grand mean and grand standard deviation. Now when we analyze again, we're going to want to look at the mean z-scores by different groups so we can tell. If we didn't do this step, they'd all have the same mean and standard deviation. So we want to split the file by lens type 2. And then we want to run our descriptives again. We don't want to calculate z-scores, and we will say OK. And it would be helpful if I would actually add the z-scores to our descriptions. So let's come down here. Z-score for age, down to z-score for baseline, and now let's say OK. Now notice that one thing before, no, I didn't do that. Okay, how about there? Nope. Okay. We have the means for each of our three groups, both the raw means and the z-scores. Now what we want to do is bring this into Excel so we can do a graph. So let's copy this, go into Excel, open up a blank spreadsheet, and paste. So we've just pasted everything in. Here's our list. It's come out to a bunch of different things. So what we want to do, let's start with a bar graph. And we're going to plot the mean z's for each group. So one of the things we need to do first, make this a little more convenient for us. I'm going to cut these columns and I'm going to move them over to here. And I'll delete these columns. And now the variable names are matched with the means. So we have a spheric, and let's copy that. Let's say insert. We're going to do a bar graph. Now remember, means have a mean of 0 and a standard deviation of 1. So now notice these guys are all, you know, squished in here. It's a little hard to read. They also have z-score on there. Now if we look over here, we see that we have this column, which are the mean values, and this column, which are the names. Now z-score is a little redundant, so let's just copy age and paste there. Now we have the individual labels. Let's look at this. We don't really want, even though the 0 is right there, we don't want these here. We would like to move them, this axis, down to the bottom. So let's right click, format the axis, go to labels, and right now the label position is next to the axis. Let's do it low. Now we've got them. Now you can read them pretty easily. Alright, now what we want to do is we want to add, this is aspheric, and now we want to add the two spherical ones. So let's go right, and I'm going to get rid of chart title because when you're publishing, they don't like to have the chart title being in there. They would prefer you explain it in your figure legend rather than having a title. But well, let's add some more data. So right click, select data. Let's give our series a name and let's call it aspheric. So I just clicked on the title there rather than typing it in again. That actually has value when you copy the chart and you move to something else and you want to keep the labels the same thing, but you want to chart something a little different. Okay, so let's add some data. The series name is going to be spheric, and the values, we can click on this little arrow right here, and this will let us come over and copy down, oops, not there, copy down our values. Click on that, okay. And we can see that we have some differences there. We'll talk about this in a second. Let's add another one. Series name is going to be good control. And it's going to be these values right here. Okay. And we're done. So let's say, all right. Now, let's add a legend. So we come to Design, Then add a chart element, a legend, and I don't know, is this going to let us legend options? I don't think so. Let's just say we want them on the right. Oh, there they are. But let's put this legend inside. OBS likes its legends inside. We're going to make this big again. We might have a little bit of a problem fitting everything in there. So let's delete that. Let's go to add a chart element, a legend. This time let's add it to the bottom. Now let's move this up here. That fits. Okay, and let's add a chart element. We have all of these are standard scores. Well, they're not standard scores. These are whoops. What did I do? Hey, come back. Where did you go? Really? There we go. Okay, they're not standard scores. These. Okay, they went up to the, yeah. I lost my legend. Can I undo one more time? There we go. There are baseline values. And let's go to design, add a chart element, the vertical, and let's call these. Now, when it comes up, you can type up in this space for what you want to put it in. And these are standard scores, parenthesis Z. Now that's all squished in over here, so we don't like that very much. So let's click and let's move this over. Standard score Z's. Now, one more thing. We want to make this optometry and vision science compatible. So we want our values to all be Arial. If you don't like Arial, too bad. You don't have to publish an OVS. And we want the font to be 8-point. Now it's 8-point for all the little text, but for the titles, we want that bolded and we want it raised to 10-point. Bolded, raised to 10-point. Some more things that we need to do is OBS does not like grid lines, so we are going to delete them. We do keep our 0 line. Now, I think they like it framed. So let's come to this. Let's give it a border. Let's give it a solid line. But they only want that solid line to be a 1/2 point in thickness. Pretty specific stuff, huh? All right. Now let's take a minute and look at the data and see what the heck is going on. Notice you can hardly ever see the aspheric points. Those are the blue ones. And the reason for that is, as I said, we started out with lens type where we matched, rather. We started out matching aspheric with spherical lenses. And so each aspheric lens is basically in the middle of the two different spherics. So there is a big difference. While the overall system matches, so every blue matches with every aspheric lens eye matches with a spheric lens eye. It's just when you separate it into those that didn't work very well to those that worked pretty well, you split the difference because they have to average out to be the same. Now, there's a little bit of difference in N in that didn't fit well, and I'm having a feeling I labeled those backwards. But we'll forget that for now. But there's a different number. So that bar is longer because of being weighted. So the spheric, the gray, has 74, so it takes more, and it comes up there higher than the more weight in this one. So that is our way of creating a bar chart. Now, one other thing that I wanted to point out, these are anemic looking little bars, and I don't really care for that. So I'm going to click on one, and notice that we can come into format our data series, and this talks about the gap width. So the gap width is 219%. Let's lower that to around 50%. And now we have bars that are much more less anemic looking. So we have age, spherical equivalence, and from this you can see there are big baseline difference between, while aspheric and spheric matched, those people that were good fit and bad fit, they differed quite a bit in spherical equivalence at baseline, eccentricity, pupil size, baseline axial length. So they were different at the start, even though they did match with all the aspheric lenses. All right, I think we're going to call it a day for the